Bismillahirrahmanirrahim. Assalamualaikum. Today my group and I will present about assignment 3 single phase transformer open and short circuit test. We are from BEEE S22/1. Our group consists of three members. The first one is Siti Diana Carmila binti Nur Azmi. Second one is Muhammad Nur Amin Shah bin Abu Bakar. Last one is Muhammad Elwan bin Muhammad Roslan. We will run the simulation on multi-sim software, and I hope you guys enjoy.
Hi, Assalamualaikum warahmatullahi wabarakatuh. I'm Mila. Now I'll present to you about the open circuit test. First of all, I will show you guys the component involved in this circuit. First is a power supply, a resistor and also an inductor parallel to each other, a transformer with ratio 750 to 820. And also we have 3 multimeter, which this multimeter will measure current. The second multimeter will measure the voltage of primary, and the last multimeter will measure the secondary voltage. As for wattmeter, we measure the power of this circuit. So first of all, we need to find the R1 here and also the L1. I will show you guys how I get the R1 and L1 next.
So how do I get R1 and also L1? So as for R1, I use the formula of V squared over P, which V squared is 230 volt square root over P, which is P are given 5 watt. So the answer is 10.58 kilo ohm. And as for L1, I use the formula of, I need to find the XM. So XM is V1 over IM. So V1 is 230 volt over IM is 60 milliampere. So the answer is 4.113 kilo ohm. So we know XM is equal to XL, which the formula is 2 pi FL. So to find L, we use the formula XM over 2 pi F. Okay, so L is, XM is 4.113 kilo ohm over 2 pi 60 hertz. So the answer will be 10.91 Henry.
So just now, I just show you guys how I can get the value of R1 and also L1, which my R1 is 10.58 kilo ohm, while my L1 is 10.9 Henry. So I will use this value of the component in this circuit. So let's run our circuit and see our multimeter. So first, we can look at the multimeter of voltage is the same, just like the value of V1, 230 volt. And as for the ammeter, shows 59.878 milliampere, which in the lab sheet, we use I as 60 milliampere. So next, we go for the wattmeter. So the wattmeter shows the value 5 watt for the power. So which also the same in the lab sheet. And now we go to the secondary voltage, which the parameter reading is 251 and 466 volt. So this represent for V2. So that's all for the open circuit test. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Nur Amin Shah bin Abu Bakar. Metric number B01 B0819104003. And today I'm going to show you guys how to simulate the short circuit in assignment 3, which is short circuit test. Assignment 3, single phase transformer, open and short circuit test. Okay, let's now here is the component that I already located in workspace in multisim. So we're going to connect first. So here is all the component. All the component we can find in the at here, and the multimeter and also voltmeter at here. So this is the transformer, which is we need to change the value of coil here. Primary coil is 750, 750, and the secondary coil is 820. Okay, so we already connected all the component correctly, and make sure there is no mistake made, because when we have the mistake, we also get the wrong answer and error. So we're going to run, and then show the multimeter here, also here, wattmeter here, and the multimeter 3 is here. So this is the reading that we get from the short circuit test. The current is 442.283 milliampere, and the volt is 22.73 volt, and this is the watt, is the power, 10.048, and the power factor is 0.999 for watt. Okay, that's all from me for part B, short circuit test. Thank you.
I will present part 5.0 is the questions. So this is a part A. So A, power factor. So power factor you can get from the multi-sim simulation of the wattmeter. So the power factor is 0.36335, and as for the angle, I use the formula P1 is equal to V1 times I naught cos theta. So the theta here we need to find. So we use the 0.362 is the product from the 5 watt over 230 volt divided by 60 milliampere. So here for the theta is cos inverse 0.362. So we get 68.76 degree. So for the IC and IM, so IC I use the formula of V1 over RC, which the V1 is 230 volt while the RC is 10.58 kilo ohm. And the IC is 21.74 milliampere. As for IM is the square root of I naught squared subtract IC squared. So the I naught is 60 milliampere while the IC is 21.74 milliampere. We squared them both and then we square root. We get 55.923 milliampere. As for the phasor diagram, here I put the V1 is 230 volt and the V2 is 251446 volt, and the IC is 21.74 milliampere. And then also for the angle, I take the angle from this one, 68.76 degree. The I naught is 60 milliampere and also the IM is 55.923 milliampere. This is the equivalent circuit for part A, open circuit test. So open circuit test doesn't have load. So in open circuit test, the current used is low because we need to gauge the secondary voltage. Now, this is the part B. First, calculate the R1 and X1. R1, I use the formula of P1 over I1 squared. So P1 and I1 are given in the lab sheet. So which is P1 is 10 watt. So over what I1, 440 milliampere squared. So the answer is 51.65 ohm. So for the X1, I use the formula square root Z squared minus R squared. So first we need to find the Z. Z is V over I, and also we need to find the V. So the V, I use the formula of square root P times R. So P is 10 watt times by R, 51.65 ohm, square root, you will get 22.73 volt. So Z, I use the formula V over I. So 22.73 volt over 440 milliampere, so will equal to 51.66 ohm. So X1, you can use the square root of Z squared minus R squared, so the answer you will get 1 ohm. For RC, I use the exact value from the open circuit test, which is RC is equal to 10.58 kilo ohm, while also same for the XM, I use the open circuit test value, which is XM is equal to 4.113 kilo ohm. So this is the equivalent circuit for short circuit. So in the short circuit, we have I naught, which is 440 milliampere, which is given in the lab sheet. So for V1 is 22.73 volt. This is the voltage that we calculate just now. Also same for the R1 and also L1. So in short circuit test, we use a very low voltage to gain the secondary current, which the secondary current is 400 milliampere. So that's all. Thank you.